young math padawans. It's Mrs. Angel with your lesson for today on choose your method for solving systems of equations. So imagine a teacher just put down a system of two equations in front of you and said, solve. They didn't tell you to graph, substitute, or eliminate. You had to figure it out. Well, technically, you could use any method on any system, but there's a reason why each method exists. Each method is unique to what that system looks like and what information it's giving you. So that's what we're going to look at in today's lesson. It's all about choosing the method that makes the most sense for the system that you are given. So grab your notes and let's get started. So we're going to start by looking at the graphing method. So I've included a couple what we would call simple systems for graphing, meaning there's no converting necessary. And here's the question that I want you to answer. What do all four of these systems in the table have in common? Go ahead, think about that and answer now. So let's see if you were able to find what they all have in common. So something that stands out to me just by looking at it is that all of these systems have y isolated on one side of the equation, y equals, y equals, y equals. So maybe I'm thinking substitution, but then I also see fractions in some of these, which kind of makes me not want to substitute. I also notice that along with the y equals, they have some type of x term and then some type of constant. That's basically saying that all of these equations are following the same form. That form is y equals mx plus b, which we know as slope-intercept form. So what these all four systems have in common is that they are all, which just as a reminder is y equals mx plus b. Now that's why we would call these simple graphing systems, because there's no converting necessary. They're already ready to go. You just have to identify the y-intercept and the slope, and off you go. Let's look at the second table. These are all what we would call simple substitution systems. All of these don't require any isolating to happen ahead of time. So same question, what do all four of these systems have in common? Let's see what you were able to identify. All four of them have one equation where the variable is already isolated. So in the first two systems, it looks like y is isolated, which means the substitution is a lot simpler to do. All I have to do is take this expression here and substitute it for y in the other equation. Same thing with the second system. Take that expression, substitute it for y. In the third system, we have x, isolated, so I would substitute for x. And then same thing in the fourth system. X is isolated, substitute for x. So all four of these systems already have an isolated variable. And notice the difference between substitution and graphing is that that isolated variable is x or y, whereas in graphing, all of them had y isolated because that's slope-intercept form. Let's wrap up with the elimination method. So now ask yourself, what do all four of these systems have in common? This was a little bit of a tougher one, but something that I noticed with these systems is that there are no isolated variables, not even close. And another thing that I noticed is that the variable terms are lined up on top of each other. You've got x's on top of x's and y's on top of y's. We call these equations in standard form. So both of the equations are in standard form with the like terms already on top of each other, already lined up. We call that standard form. And if you ever wanted to know, standard form looks like this, where you have an x term plus a y term and a constant. So let's take what we just noticed about these patterns and let's start making some conclusions of which method works best given a specific system. So on this page, we're first I'm going to give you a bunch of systems. You're going to figure out which method you would use to to solve that system based on those patterns we just saw. So let's write some conclusions from the previous page. So when would you ever choose graphing? Because graphing, we know, tends to take the most amount of time. Well, I think we would use graphing when the equations are in slope-intercept form. So y equals mx plus b. Another indication that you probably want to use graphing over substitution or elimination is if you see fractions, because fractions are much easier to deal with in graphing than they are in substitution and elimination. Okay, when would we ever consider substitution? Well, if you remember from the previous page, that's when one of the equations has an isolated variable. And remember, that isolated variable could be x or y. So there are a lot of times when graphing and substitution will overlap, because you're going to see that y isolated with graphing. But remember, substitution could be x or y. As long as you have an isolated variable, it's pretty easy to substitute after that. And then when would we ever use elimination? Well, we would only use elimination when the equations are in standard form. But since we haven't talked a lot about standard form, x, y, constant, I'll also say when the variable terms are lined up. Because remember, you need those x's on top of x's, y's on top of y's, equal sign on top of equal sign, and constants on top of constants if you want to be able to eliminate. Now I'm going to give you some systems, and you have to figure out which method would you use of the three to solve, and why would that be. So here are your systems. Ta-da! Here are the 7 systems we're going to look at, and don't worry, I'll give you plenty of time to copy them down. So we're going to first look at the first 3, determine which method, if you had to choose one, would be best and why. So take a moment and copy down just the first 3 systems in this table. Okay, so let's start with the first system. We have y equals negative x minus 1 and y equals 1/2 x minus 4. Which method would you use for this one? Of the 3, well, both equations are in slope-intercept form, and I do see a dreaded fraction, which leads me to believe that the best method here, if I had to choose one, would be the graphing method. And why? Well, 2 reasons why. Both are in slope-intercept form, and I see fractions. Blech. I do not want to deal with fractions if I'm doing something other than graphing. All right, what about the second system? 4x plus 7y equals negative 19 and 5x plus 7y equals negative 29. Which method would you use for that system? Well, I don't see any isolated variables, and I definitely don't see any fractions or y by itself, and I do see like terms on top of each other, so that leads me to make the conclusion that I would use elimination method here. Why? Well, you could say that they're both in standard form, or I have variable terms lined up. X is on top of x's, y is on top of y's, etc. Last one, 7x minus 3y equals negative 3, and y equals negative 5x plus 1. Which method would you use here? I see one equation with an isolated variable. The only variable that's isolated here is y. So that leads me to believe that the best method to use would be substitution. Why? Because one equation has an isolated variable. I do want to clear up one quick thing. Technically, you could use any of the 3 methods on any system you were given. It's about which method would you choose to make your life a little bit easier. So we're looking for these patterns, we're looking for the information the system is giving us, and then we're just going to choose the method that is probably the best choice given that system. So with that being said, take some time and finish out the table. You have 4 remaining systems. Decide which method would be best and explain why. Great job. You're going to go over those with your teacher later on. for now, we are going to move into part 3 of this video, which is our practice. Let's actually put what we just did into some practice. So we have to, according to these directions, select one of the given systems to solve using graphing. So we can only pick one to do graphing with. We can only pick one to solve using substitution, and we can only pick one to solve using elimination. So we have to pick wisely, because let's say, for example, I choose to do substitution with system 3. That means I can't do substitution with 1 or 2. I would have to graph or eliminate. So I'm really looking for those patterns, those rules, those, indicators for what works best. So let's start with system 1. What do you see in system 1 that would make you choose a particular method? What method would we use here for system 1? I see an isolated variable x, which leads me to believe that system 1 would be best for the substitution method. So that means it looks like we're going to be using substitution for system number 1. So I'm going to write down that system for underneath where we have substitution. 5x plus 6y equals -7, and x equals -y minus 2. And we'll come back and solve that with substitution later on. Now let's move on to system number 2. We can't use substitution. That's out. We're already doing that. What method would you use for system 2? I see equal terms. I see a -5x on top of a -5x. And then I also see that my y's, equal signs, and constants are all aligned. So that leads me to conclude that system 2 would be best solved using elimination. So down here, it looks like we're solving system 2 using elimination. So I'm going to copy down that system under elimination. So we have -5x plus 4y equals -8. And we have -5x plus y equals -17. So we're going to solve that one using elimination. Well, by process of elimination, for lack of a better phrase, what does that leave us for system 3? That only leaves graphing. Let's make sure that graphing is actually the best method for this system. I see y equals mx plus b, and I also see one of those dreaded fractions. So it does appear that graphing would be the best method for this system. So we would use graphing in system 3. So the first line would be y equals 2x minus 1, and the second line would be y equals 1/2 x plus 2. Okay, so now that we've decided which method we would use, it's time to go in there and actually do the work. So let's start with system 3. Pause the video now, graph, solve, and check system 3. Come back in and I'll show you the answer. All right, step 1, graph both lines. Step 2, look for a point of intersection. Looks like these intersect at the point 2, 3. Step 3, check. Done. So it would appear that the solution 2, 3 is the correct solution for the system number 3, which we used with graphing. All right, now move on to system number 1. Solve this one using the substitution method on your own now. Great, let's go ahead and solve. Step 1, we're going to substitute. Now that we've substituted, we're going to solve for y. Now that we've found y, we're going to plug it into one of the original equations and solve for x. And finally, we're going to check. Whew! All right. Well, it looks like we correctly solved the system using substitution, and our solution of -5/3 was correct. Last one, solving system 2 using elimination. So go ahead and solve this system now. Okay, let's solve it together. So the first thing I notice is that we have equal terms here. And equal terms usually means we would subtract, but we make a lot of mistakes when we subtract. So I'm actually going to multiply the bottom equation by -1 so I can add. Now that I've done that, I've created some opposite terms, -5x and +5x. So I'm going to go through, add the two equations, and solve for y. Now that I've solved for y, let's substitute that back into an original equation and solve for x. Final step, let's check. Whew, and done. So hopefully it didn't feel like any of these was too challenging because we selected our systems with a purpose. Let's quickly recap what we just learned. Technically, any method would work for any one of the systems. However, sometimes it makes more sense to use a particular method. So if both equations are in slope-intercept form or you see fractions, graphing method's going to give you the least amount of headache. That's the best time to graph. If one of the equations already has an isolated variable of x or y, then substitution might be the best way to go because that's a pretty simple step of substituting and solving. And finally, if both equations are in standard form with all of those like terms lined up, x's on x's, y's on y's, etc., then it's best to use that elimination method. That's it for today's lesson. I will see you next time.